In this video, we will be doing two proofs involving a midpoint, both using this figure here. So we'll start with the yellow one. Given AD is congruent to DC, prove that D is the midpoint of AC. So first thing, AD is congruent to DC. Now, just common sense is if a point is right in the middle and divides a segment into two congruent segments, then it is the midpoint. That is the definition of a midpoint. D is the midpoint of AC. If a midpoint divides a segment into two congruent segments, then it is the midpoint of that segment. The easiest way to memorize this is just to say this line 5 to 10 times. Also, as you're doing it, make sure you understand, literally, we're saying this point D divides AC into two congruent segments, AD and DC. That's all it is. You will find that once you learn theorems and how to do proofs, it's just all common sense. Now we will go down to we'll call it magenta proof. Given that E is the midpoint of CB, what that does is that divides CB into two congruent segments, CE and EB. Remember that what we're doing here with the hash marks is just simply bookkeeping. So CE is congruent to BE. If a point divides a segment into two congruent segments, it is the midpoint of that segment. So now that we've done both, remember a definition is where the statement is true and the converse of the statement is true. So AD is congruent to DC, therefore D is the midpoint of AC. For the second one, E is the midpoint of CB, therefore CE is congruent to EB. You need to be able to go the one way and then the other.